Okay, so let's look at an extension and the kind of the anatomy of it, and just how to get somebody started with a with an extension. So I've got a few that I worked on here. Um, let's go with one that's relatively simple that I can then load up. This is called follower loads, and just so you know, it's available to you on the ACT customer library here on the extension library. It's right there, follower loads extension. It's an extension that creates follower forces and moments to follow geometric deformation in our mechanical solver. So let's look at it. First thing you notice about the follower loads extension is where it's located. Okay, there's several places that you can place ACT extensions during development in your system. I think actually the preferred location would be under the app data folder. Okay, so let's go there first and look. So if I go %appdata% in my tool up there, and then click on ANSYS, and then I go into my V145 because I'm using 14.5. Advanced Add-in Package Extensions. This is a list of compiled and scripted extensions, binary and scripted, that I could put in here. This is one of the folders that ANSYS Workbench is going to check when it starts up to look for extensions that you're working on. Okay? Where I keep mine is another option you have available to you, which is right here in the actual installation path. I think you have to have admin rights to keep it here, but there's no difference between the two. It's just these are both just folders that ANSYS will check upon startup to look for any extensions that you want to have loaded in, that you want to have access to. Just a couple things to keep in mind. Where you keep these extensions could matter. For example, if I kept them in the app data location, that is essentially in my settings. And if I were to clear my settings and delete that folder or something like that, I would lose those extensions. So you need to be extremely careful about that. Same thing here though, where it is right now. If I were to uninstall my version of 14.5 right now, I would lose these extensions if I checked the option during uninstall to delete this directory, to delete the 14.5 installation directory. So that has actually bitten me before. I won't be, I'm not too proud to be able to admit this to you. It's bitten me before. I lost an extension I was working on. Luckily, I did have a backup though. So just be very mindful of that. You need to be careful with your extensions, because sometimes you'll be working on a large extension with a lot of information, and if you were to uninstall due to some unrelated topic, it would not be a fun day when you realize you just lost that extension because it was deleted during the uninstall. Okay, so that's for location. One quick thing here under settings is that you can choose where you want the program if you wanted to keep it in a separate one. I just went to Tools, Options in Workbench, and I click on Extensions, and you see right here additional extensions folders, and I could input any path I wanted. So if I wanted to keep it on my desktop or something, easy, put a path in right there. We'll look at this option a little more later too. Okay, let's look at an extension though. So follower loads. What I've got highlighted right now is the follower loads extension. It is an XML file, a single XML file, and a folder, and the contents of that folder. That is what compiles that is what makes up the follower loads extension. Okay, so a little anatomy. The XML file, which we'll look at in a minute, is kind of the director. It's running the show, saying what's actually going to interface with mechanical. And then in this folder, you have a couple things. Most importantly, you have your main.py. There could be a lot of things in this folder doing various things depending on how advanced your extension is. But to keep it simple, all you need is a main.py, and then generally you need a folder with images in it, and these images are used through my extension. But it's just that simple. That's basically it. This is something for advanced functionality. For now, don't worry about that DLL. So basically, you could just imagine main.py and an images folder. Alright, let's open up the XML and go through it very briefly and just try to understand what it is. Every time you open up a piece of software like this, a piece of source code, it looks intimidating, it looks complicated. Trust me, it's not. It's not intimidating or complicated. It's actually extremely logical and simple to follow. The XML file especially is. To kind of highlight that, let me shrink it down at first to just what's more simple. Oh, and by the way, I'm using Notepad++ here. It's a software I highly recommend. It's not necessarily the most advanced text editor for programming or things like that, but boy is it great. It's just fantastic to program in Python or XML language or anything. It has a lot of really wonderful functionality. It's free, it's available. Just Google Notepad++ and you can find it. Okay. So let's start off the bat here at the top of this. Let's just start at the top of this guy and look at what we've got in this XML file, because every ACT extension begins with the XML file basically. Okay, the first line, I'm just saying that I have an extension. It's version 1 of the extension. You start at version 1, fine. What's the name of the extension? Follower loads. Okay. It's, there's some idiosyncrasies you can pull with the naming, but essentially pick a name and stick with it throughout. This is going to be your name. This should be the name of the folder that's in there. You can experiment. There's ways to make it different. I don't really keep track of it. What is and isn't required. I just make it a practice to pick a single string, and that's going to be the name of it, the name of the folder. In this, in here, right here, follower loads, things like that. Okay, so then I'm going to say that what is my script? The next line is going to basically ask me, what script am I going to use? This is the pointer to your Python file, the all-powerful Python file that goes with the XML for your extension. Very simple what I'm doing here, script src equals, I put in here the extension folder, wherever it is, and then /main.py. If I wanted to name it something else, that'd be fine. I could just put it here. You can have multiple Python files. That's kind of advanced functionality, but it's very possible. You would just have more links right in here. That's fine. Okay. You might be wondering, how am I going to remember all this? Well, nobody starts an extension from scratch, right? You don't start off with this guy here saying, I'm going to build it, type in extension, everything. You're always going to start with something else. There's a million examples available to anybody online, so there's no reason to ever start an extension purely from scratch. Generally, of course, it's a good idea to get a pretty simple one and start by modifying it and going from there. So you don't have to remember all this verbatim, but this is just kind of walking you through the logic. So the next thing, the next section that I'm opening and closing right here is the interface. What interface do I want to interact with? I'm interacting with the mechanical interface. You have other options as well in terms of context you can read about in the documentation, but this is pretty basic, just saying I'm going to interact with mechanical. What images might I want to load into mechanical for my extension? Well, there's the same thing as the script up above. Here's my images folder, and the images that are in that are going to be referenced down here later, you'll see. Okay, so that's basically it. That's the beginning of the extension, and now it's time to actually get to the fun stuff, which is, how did I add this? Oh, I haven't actually loaded anything yet. We should load one in a moment. But how do I actually load a toolbar into mechanical? Well, let's start off. This is how it's going to be, but let's start off and let's load in this follower loads that we're looking at. So I'm going to close mechanical, come in here, under extensions, say manage, load in follower loads by checking it, say close. You'll see it say busy down in the bottom left here for a moment, and now it's ready. So, now when I open mechanical, you'll see that we have a new toolbar, follower loads, and it's got two nice little buttons with it, with images, okay? How did I actually put this toolbar in? Not that complicated. I have a section called toolbar. I named it, and I gave it a caption, okay? The name is under the hood, basically how you would refer to it in the code, and the caption is what actually shows up here. So notice that the name doesn't have a space. The caption does. You can do that however you want, but the one with the space shows up here because this is the caption. Okay, what's going to be in this toolbar? Well, two entries. Okay, see I've got them collapsed here. Entry 1, follower force. Entry 2, follower moment. Icon, follower force. Icon, follower moment. These, of course, correspond with these two images. And there we go. We've built our toolbar. So as you see, just from right off the bat, so far it wouldn't necessarily do anything. But that's how simple it is to just build a toolbar and put buttons into into mechanical through ACT. Okay, let's look at a little bit of the details of these guys. There's two entries in here. So for follower force, I have I have what's called callbacks. We're going to talk about in a moment, and an on-click callback referencing a function. Okay, so this is where we really get into it. This is how callbacks work, and they are a crucial part of understanding ACT and the XML file. I'm not sure if everything I describe here is proper with programming protocol and how it's talked about there. If not, I apologize, but I'm not a programmer. I'm an engineer who knows some coding and knows how to program, but that's the power of ACT, right? I don't need to be a software developer, so I apologize if this isn't exactly the proper way to put it, but it is the practical way to put it. Callbacks are essentially generally event-driven, okay? When something happens in one way or another, a callback can be invoked. So, for example, here are the list of callbacks that will go with this button, this icon, this entry in the toolbar. And the one that makes sense, we only need one because it's a simple button, is onClick. So this is saying, onClick, when somebody clicks it, what should I do? Well, the XML is saying execute this. Well, what is this? Create follower force. This is a function in my Python file that will be executed when somebody clicks that button. That's how it works. And so what I've just said right there is essentially kind of the core of the fundamental mechanics of ACT, right? There's a button or there's something in mechanical. There's a callback, event-driven callback attached to it, and when that is invoked, the XML is made aware of it by saying on click. What do I do? Create follower force. We'll go look at this function and what it does in a moment, but that's basically it. So this one has its own thing right here, create follower moment, that's actually going to do something on click for the two various buttons, and then that's it. I say done with my entry, done with my toolbar, and I'm done modifying the mechanical interface, and that's all. Okay, so as far as putting the buttons in, that's that's really what you need to know. Simple, right? There's not a lot to it. Put two buttons in and said this is what you do upon execution of them. Okay, sim data in mechanical, there's a lot more in here. Again, it looks like a lot, but it's no more intimidating than what we saw up above. It's simple when you walk through it. I'm not going to go through it in as much detail, but I'll quickly go through it. Again, I set the context for this simulation data for sim data as mechanical. And now what I'm saying is I'm adding like a load. Okay, before we get to this, let's actually look at this load. To do that, we're going to go into create follower force. What happens when I click on this guy? Here's the follower force button. I click on it. Something is going to happen in my tree, obviously. A follower force has been created. Okay, so why did that happen? Well, it obviously must have come from something in create follower force. So here we go. We'll go open up the main.py. Okay, I'm going to collapse everything by lovely Notepad++, Alt-1. It collapses everything down into just the functions that are being invoked here, and we will find that one of them is create follower force. It's a very simple function. Okay, it's only a few lines long. And it is, a Python function that's going to do things. Well, let's just look at it very briefly. Somebody just clicked on the button. So the first thing I do is I log a message in the API. See this? This should look familiar. extapi.something. This means I'm doing something in the mechanical API. And in this case, what I'm saying is extapi.log means I'm going to access the ACT log. And then, I'm going to write a message into it. And I'm writing a message that's saying, hey, somebody clicked on the follower force button. A user doesn't necessarily see that. That shows up in the ACT log we'll look at in a minute, but it's just kind of so I can track what's happened, or that somebody could track what's happened. This is what just occurred. All right, so next up, somebody clicked on it. What do I actually do? Well, I have an if statement here. I check a couple things. If analysis.analysis type, and I'm going to talk in just a moment about what this analysis is. But essentially what I'm checking here is the analysis type for this problem either static, or transient, or harmonic, and is the solver name ANSYS. What I'm doing here is I am making sure that the analysis this object is being added into is an analysis that can accept it. Only static structural, transient structural, and harmonic analyses utilizing the ANSYS APDL solver will accept a follower force, which is the purpose of this entire extension, and therefore, if it's not true, if these statements aren't true, I'm going to throw a message box error, and the user will get a pop-up that says follower loads can only be added to static, structural, transient, harmonic, blah, blah, blah. Okay? But if it is true, here's the actual action that's being taken. Load is equal to analysis.create load object follower force. Okay? This is a built-in thing saying I'm going to create a load object in the tree, and I'm going to name it follower force. Okay, and sure enough, that's what happened. A new load object, and it's a load object. It shows up under the environment, and it's basically saying some kind of load of some sort has been added. There are other options besides create load object. There's create results object that would add one down here in the results section, things like that. All that can be found in the manual and things, but this is kind of the basics of how it works. Okay, almost done here with really what I wanted to show in this video, but one last very important concept is what I promised to come back to earlier, which is why I would not generally say, notice that I did not say that I wanted to add this under analysis list 0, because maybe somebody would have, right-clicked and said insert follower force, and by the way, it shows up both in this drop-down menu and as a toolbar. That's nice. Somebody might have said this on like the 5th down analysis, and I don't want to hard code in there that it's going to go into analysis as 0. This is a very important concept I'm about to say again with ACT, one of the fundamental concepts about using the actual interface here. What is passed in this create follower force function, and what it really means is what's passed in any thing that is on the on-click callback in this toolbar here. There's one thing passed, and that is the analysis. Which analysis are we dealing with? And what that means is that I put a word in here, analysis is the normal word basically, that is itself going to be a variable utilized throughout this function that will have the properties of ext.api.datamodel.analysis_list whatever analysis I'm on. Okay, it's dynamic and it's chosen for you, so you don't have to worry about it. So again, if I came down here, if I had another analysis and I right-clicked on modal in here and put in another follower force, it would show up in that one because it was interpreted, as analysis was interpreted as the current analysis I was clicked on. That's really fundamental and very important. It would be improper to program an ACT extension that said explicitly here extapi.datamodel.analysis_list1 or 0 or whatever, because it might not always be that one, and your extension won't be as robust as it needs to be. Also, if you're wondering how you would know which objects will be passed with various callbacks, for example, in this callback, the analysis object is being passed, you can find that in the documentation. Each one of the callbacks utilized in ACT can be looked up in the documentation, and it will tell you what it's expecting. So maybe it will say, I'm expecting you to pass the analysis for this, for this given callback, or maybe it'll say the load, like for the load object, if it's a callback associated with the load. But that's where you would go. The documentation is a good place for things like that. So that's the basics. Everything in this extension kind of flows from there. Just a very brief overview now. I've kind of gone into as much detail as I'd like to in this video for the initial parts, but then the brief overview for the rest. The XML has details on that actual load that's been added, okay, and things. So I have callbacks here, on show, on hide, on suppress, on unsuppress. You kind of get it, right? This is what is occurring when different things happen, like this event is shown, or like this object is shown or hidden. And shown or hidden would be clicking on it means it's now shown, clicking off it means it's hidden, things like that. So I have all sorts of things in here, like a function on show. We can just look at it briefly and see that on show comes in here and says, wait, was that my on show? I don't think so. Oh yeah, on FL show, perfect. All it does is it invokes another function called draw graphics, which is used by multiple things, so it's its own function. I do some graphic stuff in here. Graphics in ACT can get a little complicated at first. You work through it. The example that you have on the customer portal here, which is this one, is quite well laid out. I think I did things that are pretty useful that you could go through. But it all links together like that, and everything I just went through is really the core of the understanding of how ACT works. So you go back into this XML, you're going to find a bunch of callbacks. You're going to find that they've invoked functions in the Python, and that those Python functions do things in general. Just to show you one thing about, one of the most common things people would do ACT with would be for adding a thing like this, adding APDL script under the hood. Just so that I don't leave you without seeing kind of generally how that works, what I've done is I have one of these guys on here will be on solve. I'm just going to search for it. Okay. Get solver commands, excuse me, I misspoke. So get solver commands for this thing. Notice this is a callback that exists under the follower force load. Okay, so just to refresh, somebody clicked the button, create follower force, created a load. In the tree, here's details for that load. And one of the callbacks is when the user hits solve, do this. Here's the function. Okay, write follower force. Let's go look at it. Okay, it's one of the most complex, obviously. It's pretty long, it's 100 lines, and it's got a bunch of stuff in it. But really what it's doing is it's mining a bunch of information out of this details box, which is all created in the XML and Python together. No more complicated than what we looked at before, really. It's pulling a bunch of details out of there, doing things like extapi.whatever, what did the user choose for remote point, stuff like that. And then it's converting that with, programming or math or whatever into APDL commands using stream.write. And this basically is going to put it into the ds.dat file, which is the Workbench Mechanicals file that it composes to submit to the ANSYS solver. We say, okay, stream.write, and I'm basically just building it up here. So notice a bunch of this is just kind of static APDL commands that I need, but then I have to every now and then put something in. So I have RPN as a variable. I convert RPN to a string and put it in the line here, comma, whatever. That's essentially how it works. Again, go through the examples, go through the training, the documentation, and absolutely contact us anytime. Please feel free to contact me directly. I'm an ANSYS support engineer. I'm more than happy to help you, and I'll give you my information at the end. But within the scope of this recording, that's basically it, kind of the basics of creating and how to get started doing a command. Obviously, I've got a lot of work went into this, but to start off simple, try to create a command that puts a button in there, and when somebody clicks it, just does something simple, like pops up a message box that says, hello. We have an extension called High Five that you can download that's essentially the answer to that if you're having trouble. But try to do that on your own, and you'll be well on your way to creating ACT extensions. Okay, that's it. Thanks a lot.